In this video, we want to talk about ports. A single device with one IP address can host many different services at the same time. A PLC might run a Modbus service for SCADA polling, a web server for its configuration interface, an FTP service for firmware updates, and an SNMP agent for network management, all simultaneously. When network traffic arrives at that PLC's IP address, something has to direct it to the right service. That something is the port number. Understanding ports is essential for reading firewall rules, for interpreting network logs, and for knowing exactly what your OT equipment is exposing to the network. If the IP address is the street address of a building, the port number is the suite number inside. When traffic arrives at a device, the operating system reads the port number from the packet header and routes it to whichever application is listening on that port. Port numbers range from 0 to 65,535. The numbers from 0 to 1023 are called well-known ports and are assigned to specific standard services by the Internet Assigned Numbers Authority. Port 80 is HTTP. Port 443 is HTTPS. Port 22 is SSH. Port 502 is Modbus TCP. Port 44818 is Ethernet/IP. You don't choose these arbitrarily. They're standardized so that clients always know where to look for a given address or a given service. Here's an example. Two packets arrive at IP address 192.168.1.10. The first packet is addressed to port 80. The operating system hands it to the web server. The second packet is addressed to port 502. The operating system hands it to the Modbus service. Same IP address, but completely different destination based entirely on the port number. An open port means a service is actively listening for incoming connections. Every service is software, and software has vulnerabilities. Every open port on a device is a potential entry point for an attacker. This isn't theoretical. When attackers scan for targets, they send probes to common port numbers looking for services that respond. A PLC with port 502 open and reachable from a corporate laptop network is visible to anyone who can reach that network and knows to look. If the Modbus service has a known vulnerability, and many older implementations do, that open port is the door. The principle is pretty straightforward. If a service is not needed, disable it. Don't leave ports open because they were open when the device arrived from the factory. Factory defaults exist for ease of initial setup, not for operational security. A PLC that was commissioned a decade ago with its web server enabled just in case someone needs to configure it still has that web server running today, still listening on port 80, still accessible to anything that can reach the device. A brief clarification that comes up in firewall rules. Every network connection involves two port numbers, not one. The destination port is the well-known port number for the service being reached, like we just said, port 502 for Modbus, port 443 for a HTTPS web server. This is the port you care about when writing firewall rules. The source port is a high-numbered, randomly chosen port that the initiating device uses to track the connection on its own end. When your SCADA server connects to a PLC on port 502, the server might use a random source port 54223. That number changes with every new connection. When the PLC responds, it sends data back to 192.168.1.5 on port 54223 so the SCADA server knows which connection the response belongs to. Firewall rules almost always specify a destination port, not a source port, because the destination port is the consistent, fixed one. If you see a firewall rule that specifies both a source and destination port, the source port is usually left as any. For every OT device you're responsible for, two questions are worth asking. First, does this device need each port it currently has open? Second, who specifically should be allowed to reach each open port? OT devices often ship with many services enabled by default. A web management interface, Telnet for legacy configuration, FTP for file transfers, SNMP for monitoring. Some of these services may be required for operations. Many of them aren't. Disabling unnecessary services closes ports, reduces attack surface, and simplifies the firewall rules needed to protect the device. For the ports that do need to remain open, the access list should be specific. Port 502 shouldn't be reachable by every device on the network. It should be reachable only by the historian server and the SCADA server that actually need it. A firewall rule that says permit any source to port 502 is functionally the same as no firewall rule at all. In the next video, we'll go through specific port numbers every OT engineer should recognize. Both IT ports that appear in security discussions and the industrial protocol ports for Modbus, Ethernet IP, DNP3, and others.